let's get started. The way I want to start tonight is with a couple of quick, what I refer to as disclaimers. The first one is, I'm not from around here. I'm from north of the border, up in Scotland. And up in Scotland, we tend to speak a little bit differently. For example, if I was to say to you, how are you today? I would probably say something like, fit like a day. I point that out because I've got a tendency to start speaking like that under nervous situations in front of people. So if I start speaking in any way that's not the Queen's English, feel free to put your hand up and tell me to wind my neck in, as we might say up the road as well. The second disclaimer that I want to make is that for anyone that knows me, I'm a Windows guy through and through. I've always had a Windows PC. I started a new job last Monday, which involves me working for the Chocolatey open source project, for anyone that's familiar with that. And I got given a new Mac to do that development work on. So last night when I gave this presentation at the London.NET user group, there was a couple of hitches, and it was down to me not really knowing how to use the Mac. So if anything happens tonight where things break, I would ask you to give me a little bit of leniency, and we'll move on after that. Okay? So what we are here to talk about tonight is the open source project called Cake. But what I want to do first of all is make sure that we are all talking about the same thing when it comes to what I refer to as a build. Everyone kind of has their own interpretation of what a build is, what steps are included within a build, and for the purposes of this talk, I just want to make sure that we're all talking about the same thing. So I talk about this thing called the typical build workflow. The typical build workflow starts, in my mind, I mean, we're all .NET developers here, I'm assuming. We have a compilation step. We need to take our source code and we need to compile that down into something, whether it's an EXE, whether it's a DLL, whether it's a whatever. But we have that compilation step. That's typically happening within Visual Studio. And because we're working in Visual Studio and we're working in the .NET ecosystem, we're probably pulling in some third-party dependencies from everyone's favorite tool, NuGet. So in this typical build workflow, we have a package restore step. Now again, within Visual Studio, that kind of thing happens implicitly for you. If you open up a solution, you're going to get that NuGet package restore is going to happen in the background, and then you're going to be able to do your build step without any problems. Because we're all good citizens and we know that we need unit tests, everyone's got unit tests in their applications, and as part of our typical build workflow, we want to run those unit tests. In order for those unit tests to run in a repeatable way so that we get the same consistent build results and unit test results every time, our typical build workflow might include a clean step. So a clean step is literally cleaning up your bin directory, is cleaning up any build artifact folders that you might create as part of the build. So every time you run the build, you're getting the same result again and again and again, okay? Because we want to look at our application from a higher level and we want to know how it's progressing, are things getting better? We might want to incorporate things like test coverage. So you might use tools like ncover or opencover to take the unit test results from whatever unit test framework that you're using, pass them through a test coverage utility, and then you'll get a pretty HTML report out that says my test coverage is getting better or it's getting worse. If you're anything like me and you like to run your code through lots of static analysis tools because you really worry that there's an extra space at the end of a line or the curly brackets are in the wrong place, you might use tools like what are up there. So you've got StyleCop, DupeFinder, FXCop, InspectCode. They're some of the main ones. But again, it's just this concept of what is your typical build workflow, and this is the kind of exterior things that you might add in to your build workflow to make sure that it's doing what you want it to do. Now, having done all of those things I've just spoken about, we don't actually get anything back from it until we start packaging it up. We need to get to the point where we are packaging up that application and we're starting to push it out to our customers. Once that's when you start getting revenue in and you start making money. So the packaging step in a typical build workflow might be to generate an MSI for installation purposes, or it might be to wrap your application into a NuGet package so that you can push it out to nuget.org, whatever it is. And then naturally from that, there's a publish step. And that publish step is literally just taking what you've packaged up, what you've built and you've unit tested and you've packaged restored, and pushing it somewhere, putting it onto an FTP server or whatever your workflow is. So hopefully there's nothing too surprising in that typical build workflow. Obviously your situations are going to be different. You're going to have slightly different steps, but this is what I'm kind of going to refer to as part of this talk, and I'll be referring back to it. So hopefully that all makes sense. So the aim of this talk, first of all, is to answer a couple of questions, and after I've hopefully answered those questions, I'll move on to a demo of how we can piece it all together. So the first obvious question is, well, what is cake? So I like to show that it's not this. So anyone who came here expecting to get actual cake should have come to the Oxford.net user group, because they actually did have cake and you got to eat it, but there's none here. So you're not getting any cake. There was pizza, so that's a nice close second. What we are going to talk about instead is this cake. So cake is an open source project. It's on github.com under an MIT license, so I'd encourage you to go and check out the source code. It was started by a Swedish guy called Patrick Svensson back in 2014. Patrick was, and still kind of is, a build engineer. He sat and wrote MS build scripts all day long, and he got bored of it, so he didn't want to write MS build anymore because he didn't like XML anymore. So he created this tool called Cake. The project was shortly joined after that by another Swedish guy called Matthias Karlsson, and then I joined the project tail end 2015, and since then we've had two other maintainers join the team. We've had Martin, and I always forget how to pronounce his second name. He's Finnish. He's got like a weird umlaut thing in his name. I don't know how to pronounce it, so it's just Martin. And then there's Alistair Chapman, who's from Australia. So we've got a core contribution team, and we like to think that the project is in quite a good place. We've had over like 900 pull requests. We've had over 1.5 million downloads on nuget.org. So we're in a reasonably good position. We know that a lot of people are using it, and we like to think that we're kind of doing what people want in terms of their build systems. So I haven't actually answered what is Cake yet, really, but from our website, Cake is a cross-platform build automation system with a C# DSL to do things like what I spoke about within that typical build workflow. Moving on from that, what I want to talk about is, well, how does Cake actually work? So for the purposes of this talk, Cake is either an EXE or a DLL. I'm not really going to get into the technical details of what's going on there. It's literally to do with whether we're running on full framework, full .NET framework, or whether we're running on .NET Core. For the purposes of what we're going to discuss today, Cake is essentially just an executable that will be executed somehow. Okay? So that executable we can get from lots of places. We can get that executable from NuGet, from MyGet, from Homebrew, from Chocolatey, from GitHub. We've almost got some Docker images where you can run Cake directly from a Docker image. We're not quite there yet. But having got that Cake executable onto your machine, what you can then do is then you can pass in a series of arguments or configuration parameters to make Cake execute in the way that you want it to. So what you're going to do once you've got that set up and on your machine, you're going to create this thing that we refer to as the build.cake file. That's a file, as long as it ends in .cake, you can call it whatever you want. But into that build.cake file, you're going to write C#. And you're going to write C# that takes all of those things I spoke about in that typical build workflow. Think of each of those blue boxes as a task. You're going to create your tasks, and what Cake is going to do is it's going to look at all the dependencies that you define within each of those tasks, and it's going to create this thing called a directed acyclical graph, which is just a really fancy term for saying that for all the tasks and all the dependencies, make sure that you run it in the order that those dependencies define it for, and make sure that you run that task only once. So by building up this directed acyclical graph, you can control how the build actually starts to begin to get orchestrated. Okay. On top of the C# that you're going to write into that file, which is the task definitions, we've got these things called preprocessor directives. I'm not really going to go into these in too much detail because we go off in tangents and I want to kind of keep the talk constrained. But the one I will point out is if we go back to that typical build workflow where I said you might want to run unit tests. In order to run a unit test, you have to have an external tool. So let's say that you're using XUnit. In order to run the XUnit test that you've got within your project, you need to use the XUnit console runner. So if you're doing that within Visual Studio, you probably got the XUnit extension installed so that you can just click a menu option and run those unit tests. When you're running a build outside of Visual Studio, you have a requirement to go and grab that tool. So what Cake provides is something we call the Tools Preprocessor Directive. It's a mechanism to say to Cake, I need this tool, and where am I going to get that from? So the example of the XUnit console runner, that's available on NuGet.org. So you would just create a tool preprocessor directive and say, go and grab me that XUnit console runner and put it onto my machine. Once Cake's done that, it's in a well-known location, and then you can use that tool within your Cake script. And we'll come on to that a little bit later. So what we're then going to do, once we've got those command line arguments, we've got the build script, we've got the tool preprocessor directive, we're essentially going to hand that over to Roslyn. So Roslyn is Microsoft's compilation engine, and it's going to compile that script. It's going to compile it into something that can then be executed. That execution will then happen, so it'll run through all the tasks in order, and if for whatever reason there's a syntax error within your Cake script, you're actually going to get a compilation error, so it's actually not going to compile that script. So you're going to get this similar results that you get in Visual Studio if you had a syntax error within your code that you're writing. So once that execution's happened, the output of that execution can literally be whatever you want. It can be the creation of a NuGet package, it can be the creation of an EXE or an MSI, it can be handing over to Octopus Deploy to do a release, it can be pushing up to Azure, it can literally be anything. It is, at the end of the day, Cake is really just an orchestration tool that's written in C#. So anything that you can do in C#, you can do within a Cake script, and if you need to, we've had examples of people deploying and running things on Arduinos and all sorts of weird and wonderful things. So it's literally whatever you can run C#, you can do whatever you want with Cake. Okay? I normally like to stop there and just ask if all of that makes sense before we move forward. Anybody got any questions on what I've said so far? If not, we'll plow on. Okay, so I spoke earlier that Cake has this concept of tools. So one of the common questions is, well, what tools can I use with Cake? So I like to show this. It's slightly out of date now, but the ones that are in black are all the tools that come out of the box within Cake. So as soon as you get that Cake executable, straight away, you're going to be able to run things like git link, you're going to be able to run git version, MS build, XUnit, NUnit. All the ones that are in blue, and there's actually more of them now, those are ones that have been contributed by our community members within Cake. So there's quite a lot of contributors to the Cake project out with the core team, and they've looked at tools that they utilize within their build system, and they've created these things that we refer to as add-ins that bring those tools into the Cake ecosystem. That's actually where I started with the Cake project. I am also a contributor, well, I now work for Chocolatey, but I was a contributor to Chocolatey prior to that, and I noticed that Chocolatey wasn't part of Cake, so I couldn't create a Chocolatey package as part of my Cake execution. So I first of all created it as a third-party add-in, and then it got pulled into Cake proper. So what we like to say is that if there's not a tool that you use in Cake already, it's quite a simple process to go ahead and get that added in. There's now over 200 third-party tools for Cake. So pretty much everything's covered now. We get the odd one here and there cropping up, but typically the main ones that you want to run as part of your build are already within Cake. So the other question that I like to address is, okay, I get what you're saying, but why do I actually need Cake? What's the benefit that I get from Cake? So the scenario I like to describe here is that if you are a standalone developer, or you're in a team, but there's one guy who always does the build, and he does it on his machine. He does it on his copy of Visual Studio. He does the right-click build. He does the right-click unit tests. He does the right-click publish to website, whatever. You're adding what we refer to as the bus factor into there. If there's one guy who does that build and he knows how to do it, if that proverbial bus comes along and knocks him over, then your build process is shot. So what we need to strive for is a mechanism, however it is, we need a mechanism to make that build repeatable, maintainable, and reliable across the entire team. And better yet, if we can take that build and move it off onto a continuous integration server, then all the better, because we're then in a position where we can run that build wherever we need to without relying on that one person or that one machine that's got the right version of the SDK or the right tools installed. If you bring that all into a cake script, and that cake script becomes a version controlled artifact within your repository, then you can look at the history, you can see what's changed, and so on. So we're going to move towards that end goal. So what I like to show there is we kind of dog food cake. We build cake with cake, obviously, and we build it on 9 different CI servers on 3 different platforms. So you might think that that's a little bit excessive, and it probably is, but I would encourage you to go and meet Matthias. Matthias loves continuous integration and he loves to have it all set up. So he went ahead and created our system that we have building every commit and every pull request goes through all of these servers now. There is actually a good reason for it. The reason that I normally speak about here is that tools like XUnit actually behave differently if they're running on a CI server. XUnit will actually detect that it's running on, say, TeamCity, and it will use TeamCity's service messaging to write the unit test results out to a different location than it would otherwise if it was running on another CI server. So because we tap into TeamCity as part of Cake, we need to make sure that we're not doing anything that would inadvertently break things like XUnit. So we do like to run it on multiple CI servers just to make sure that we haven't introduced any regressions or any backward incompatibilities. The eagle-eyed amongst you will probably notice that we had a couple of build errors. I'm happy to say it wasn't really our fault, but it does highlight that no one's infallible. Travis was just having a really, really bad day where it didn't like NuGet.exe, and the package restore was essentially failing as part of the build. But the takeaway from this is that in order to build Cake with Cake, we have a single build.cake file, and we just put that into all of those CI systems as a single step within each of those CI systems, and we can run that build on another environment. We don't have to go through the configuration that you need to do within, say, TeamCity to create multiple build steps and have multiple build configurations. It's one build task within that CI system, and it's just running that cake file. Okay. So the other question that normally comes up is, well, this is great, but there are other build systems out there. So why can't I just use Fake? Or why can't I just use Make? Or why can't I just use CMake? You see where the names are coming from and why we chose Cake? Yeah. Or why can't we just use MS Build? Or why can't we just use Nant or Saki or Bao or some other in-house built build system? So what I say to that is, go for it, right? The main takeaway from this is that you want a repeatable build that is maintainable and reliable. Whatever you want to create it in, you go for it, right? I'm not going to stand here and tell you that you have to use Cake. I would prefer that you use Cake because it's the project that I work on, obviously. But if you want to use Fake or Make, then go for it. What I do say though, and this is the reason that I started using Cake, I used to be the maintainer of the Saki project, which for those of you who don't know, Saki is the PowerShell build automation framework. So it allows you to do exactly what I've described with Cake, but you write it in PowerShell. The problem with that was that I was the one person on the team who knew how to write PowerShell. Therefore, I was the one person on the team who knew how to write the build script. And therefore, when the build failed, it was me that had to fix it. So that's not a great position to be in because that is the bus factor all over again. So the argument that I use is that if I'm developing in C# all day long for writing a web app, for writing a Windows Form application, whatever it is that you're doing, I can then avoid the mental mind switch to having to go to another language to write the build and to maintain the build. So what I do like to say is, if you're writing F#, then use fake to do your build script. If you're writing a PowerShell application, then use Saki, because then you avoid that mental mind switch. I have heard people say that using, I'll pick on fake a little bit, I don't mean to, because I do like fake. A good way of learning F# is to use it to write the build script. And that's fine until the build's broken and you really, really need to fix it. That's not when you need to be learning F# in my opinion. But I know there are those in the audience, like John, that might argue with me, but that's okay. Let's all just be friends. And I say use what you want, okay? So what we're going to try to do is we're going to try and create a build script in Cake, and we're going to take that typical build workflow that I spoke about before. We're not going to do everything because we're not going to have time to do everything, but what we are going to try and do is take 4 of those tasks, and we're going to write them into a Cake script, have that Cake script executed, see how it's all piecing together, and have something that's built at the end of the day. If you are interested in following along afterwards, you can find all the source code and the slides on that link there. It's just a GitHub repo. Like the previous presenter, I will send this out, or Kev can send out the links to everything later on. So with that, I'm going to switch to the demos. I've got my machine set up in an offline mode. So rather than calling out to NuGet.org to resolve the packages that I'm going to be using, I've got a Nexus repository, which is just a local version of NuGet essentially. And I've modified some of the Cake files to allow that to function in an offline capacity. When you are following along at home, and if you are interested in following along, the commands that I'm going to run and the things I'm going to do are exactly the same as you're going to do them. It's just that I've tinkered with them a little bit. But I just want to point that out just so that there's no concept of smoke and mirrors going on. The other part of the demo that I'm going to do is all of the demos are done in Visual Studio Code. We, as the Cake team, ship a couple of extensions, one for Visual Studio Code and one for Visual Studio, to make Cake, or bring some of the Cake concepts, the Cake functionality, into those IDEs. The reason that I show it in Visual Studio Code is because Visual Studio Code is just easier to write an extension for. If anyone's had the privilege of writing a Visual Studio extension, it's a little bit hard. So some of the functionality that we've created for Visual Studio Code doesn't yet exist in Visual Studio. Therefore, I show everything in Visual Studio Code. So most of the things I'm going to show you can do in Visual Studio, but the best way it works would be in Visual Studio Code. Okay. So with that in mind, we need to start somewhere. So what we've got here is literally the most amazing website that you've ever seen. It's the output of .NET New at the command line. So there's very little actually in the website itself. It's just the raw template that comes from that starter project that Microsoft provides. What we're building isn't actually really the important part. Obviously, we just want to build it and see how that Cake script can be created. So what we need to start with is we've got the source code here. We need to get Cake downloaded onto this machine in order for Cake to execute. Okay. Now the way that we do that is we do that through a concept that we refer to as a bootstrapper file. So we have a bootstrapper file for both Windows and for Mac and Linux. There's some controversy with regard to the bootstrappers and whether they do too much or they do too little, or whether they should be done differently. That's a big discussion that we're not going to get into today, but bottom line is that bootstrapper file is there to serve one purpose, which is really to get the Cake executable, download it onto your machine, and make it ready for execution. What we do like to say is that those bootstrapper files can be modified. So if you need to do something specifically with your environment to do something in addition to what we provide, go ahead and do it. we're not going to try and make the bootstrapper cater for every single eventuality. We're going to give you something that works in the 90% of the time, and if you need to modify it, go ahead and modify it. Okay? So the way that we can get that bootstrapper file into our system is through some of the functionality that we provide into Visual Studio Code. So we provide a number of commands that are available just from the command palette, one of which is to install a bootstrapper. So if I select the to install a bootstrapper, I'm going to get the option to either download the PowerShell bootstrapper or the bash one. So because I'm on a Mac, I'm going to go ahead and build or grab the bash.sh file. So in there, you're going to see lots and lots of stuff. Again, that's not really important, so we're not going to spend time looking at it. But the end result of that script is cake.exe is going to be downloaded onto the file system, and it's ready for execution. It does a few other things, and if you're interested, I would encourage you to go and look at it. Okay. So now that we've got a bootstrapper, which is going to grab the cake.executable, we need a build script. So if we go ahead and create a build.cake file here, and obviously the most important part of any extension is that we've got the icon in there. So that's the cake icon. So that was the first thing that the cake extension did. Now that we've got that build.cake file in there, if we actually try and run our build, so we go ahead down here, that's the other thing, I'm using the built-in terminal within Visual Studio Code. It's just because it's easier to show everything together. Obviously you could do this from whatever shell you want to use. If I go ahead and run that build.sh file, and I show over here in the tools folder, currently there's nothing in there apart from this thing that we call the packages.config file. The packages.config file is a way to pin to a specific version of Cake. So we as the Cake team try really, really hard not to introduce any backward breaking changes when we release a new version of Cake, but it does happen from time to time. What we say is if you create that packages.config file and add that into your source control repository, then you will always get the same version of Cake when you run the build. So if we do introduce a backward, a non-backward compatible breaking change, that your builds are still going to work. So they're still going to be reliable, they're still going to be repeatable because you've pinned to a specific version. So if I run that build.sh file and we look at that tools folder, what we'll see is it's gone off, the bootstrapper's gone off, it's grabbed all of those things that we needed, and it's put them into that tools folder. So the tools folder is where Cake puts everything by default. But because we've got nothing in our build.cake file, it hasn't actually done anything. We haven't actually achieved anything because we haven't written in anything into our Cake script. So what we can do instead, and this is the other thing I need to admit, I type really, really badly when I'm trying to talk, and there's a bunch of people watching me. So I've got some snippets within Visual Studio Code that saves me having to type everything out. So I apologize if that annoys anybody, but it's better than watching me try and do it live. So what we need in the first instance is we need kind of the main things in the Cake file. So if you refer back to that directed acyclical graph that I spoke about before, we need an entry point for our build. We need to say where we want that build to start and what's the default task that needs to happen. So that's typically done by passing in on line 11 here and the name of a target that you want, a target or a task that you want to execute. So on line 11, I'm saying there, run me the target that is contained within the variable called target, and in there, I'm accepting a command line argument called target, and we would give it a name. So if we don't pass in a command line argument called target, it will default to default. So what's going to happen within here is the default task is going to be executed. The default task has a dependency, i.e. is dependent on .NET Core package restore, and the .NET package restore step up here at the minute does nothing. So again, we haven't really progressed that much further. If I go ahead and save that. So, but if I do run that build.sh file, what we're going to see in the output down at the bottom here is that it's actually gone ahead and it's ran that .NET Core package restore step. There's nothing in that task, so again, it doesn't do anything, but we're starting to see how that directed acyclical graph is starting to be built up during the execution. Okay? But if we go up to this task and we say, actually, let's put something in there, so that something is going to be this. So that .NET Core restore is what we refer to as an alias. Within Cake, all of the tools and add-ins that we have create these things called aliases, and that's really the C# DSL that I spoke about in one of the earlier slides. We're adding methods that can be executed or put into your Cake script that are then type safe in a way. So rather than you having to know that the tool that you're calling, in this case, which is the .NET CLI, rather than having to know that it's .NET restore, passing in the path to the solution file, and then some arbitrary command line parameters for that function that you're trying to call, you don't have to worry about that because it's all available in a class that you can get access to, and it has properties and you can set those properties. So what I'm saying here is go ahead and run the .NET Core restore alias, which is running .NET CLI with the restore command, pass in the location of the project that I want to restore. In this case, it's the one that's in my source folder. And so that I can show something happening, let's use a local packages folder as the packages directory rather than the global one that would be used by default. So if I go ahead and save that, and if I expand this source folder, we'll see just now that there's not a packages folder local to that source folder. If I go ahead and run that build, what we should see is that a packages folder will be created, and into that packages folder we will have all of the NuGet dependencies that my project, my web application, requires. Okay, so there's no real smoke and mirrors going on here. What we've done here at the command line essentially is what would happen for you automatically if you open this project in Visual Studio Code or Visual Studio. That NuGet package restore step is going to happen in the background for you automatically. But because we said that we're trying to move away from it working on one person's machine or within one person's IDE, and we want it to run anywhere, we have to take ownership of on all those things that happen automatically, and we need to bring that into our build. Okay? So where the repeatable essence comes into it, if I go ahead and for some reason I delete that packages folder and I run the build again, it's going to do the same thing again and again and again. So I'm kind of laboring the point a little bit, but the important part is that we're creating something that is repeatable and it will happen the same each and every time we run the build. Okay? The other part of that is obviously with that packages folder there, if I do run the build again, it will attempt the restore, but because those packages are already there, it'll just zip through it, it doesn't need to do it again. Okay? Making sense so far? Beautiful. Okay, so if you cast your minds back to what we're trying to achieve, we've now done a NuGet package restore essentially. So what we need to do now is we need to do a compilation step. So we need to take that ASP.NET MVC website and we need to actually compile it. We need to get some output. So if we look just now in the bin folder, there is actually something there. Something during the NuGet package restore actually creates that folder. I'm not actually sure what's going on there, but I'm just going to delete it just to prove it out. So if we go down here and we go to a second demo, so this second demo is using another alias that comes in with Cake, which is just the .NET Core build. So again, all we're doing here is we are orchestrating the .NET CLI, and this time around we're running the build command, and it really only needs one parameter, which is the location of the project file that we actually want to build. So if we go ahead and make one other slight change, so right now what I said before was that the default task, which is the default entry point, it currently has a dependency on the .NET Core package restore step. So we need to change that slightly, because what we want now is we want the build task to be the one that's run first, because it has a dependency on the NuGet package restore. So what I need to do, if I go down to this one and change this to be build, then what will happen is it'll go to that default entry point, it will run the build, or it'll run the NuGet package restore first, then it'll run the build. So over here now, we've got the debug output, which is the compiled DLL, all the things that need to be built as the artifacts of that project. Okay, so just to labor the point slightly, just to show how that works, if I go down here and I specify target equals, well, that's going to be a long one to type out, but let's do it, .NET core package. Did I type that right? I didn't. So if I do that, then what's going to happen at this point is I've changed that entry point. So I'm only going to run the NuGet package restore at this point rather than the build and the NuGet package restore. So depending on how you're creating the build script or what area of the build you're actually working on at any point in time, you might want to change the entry point so the build can actually do different things at different times. So that's just the way that you would do that, okay? However, if we cast our minds back to when we're in Visual Studio and we're doing a build, then one of the drop-down lists that you have at the top is to specify whether you're doing a debug build or whether you're doing a release build. So again, we want the ability to control what configuration of build we're running at any given time. So if I take that .NET Core build alias out of there and I put in a slightly more complicated one, it includes some additional settings. So again, this is the settings class that we used before within our NuGet package restore. I can pass in a configuration value to that setting so I can control what kind of build I'm actually executing. So if I go up to the top here and add in another parameter, what we're now saying is I'm going to potentially create a configuration parameter that allows me to control what kind of build I'm doing at any point in time. So just to prove that out, I'm going to go ahead and delete that bin folder again. And if I come down here, it's not actually what I want to do, but we'll let it finish. So if I go down here, delete that, and say configuration equals debug, then that's going to be the same as what we were doing before because the default configuration is debug. But what we'll see here in the output in the bin folder is that we've now got a debug release. And if we go over here and we change that to be release, then in addition to the debug folder, we've then got our release folder. So again, it's just a way to control the orchestration of the build and see how those things are piecing together. Okay? Now that we've got the NuGet package restore happening, we've got the build happening, what we spoke about is the concept of doing a publish. So we need to take the thing that we've created and we need to put it somewhere. So in your environments, that might be to deploy to Azure, it might be to a local website that's hosted somewhere. In this scenario, I'm just going to publish to another folder on my file system. So we're going to take that thing, we're going to publish it into another folder. That's the easy option, but it's the one it demos quite well. So if I go down here and add in another task that says the publish step. So in the publish step, again, we're just using another alias for .NET Core, which is the .NET Core publish step. It also accepts a set of settings. Again, we're passing in that configuration option. And the other thing that I'm setting here is the output directory. So where do you want that output of that publish to go to? So in here, I'm just adding it into the build artifacts folder. So I save that, and I remember that I actually want to change my default task again to be publish, and save that. Then that should go back to the default. There we go. Over here at the top, we should then get a build artifacts folder. And that build artifacts folder, once it gets created, it's doing the publish step now. Now we get, he says, there we go. Now we've got a build artifacts folder. So that build artifacts folder has the compiled DLL, it has the CSS files, it has the HTML files, all the things that are that website, meaning I could take the contents of that file, put them onto an IIS server somewhere, and that website would run. And that's really that demo completed. However, the thing that I like to point out here is that we've spoken before about having a maintainable, repeatable, and reliable build. It was sort of happenstance that that output folder, that build artifacts folder, got created for us. It got created for us because the .NET CLI, based on the parameter that we passed in, happened to create it for us. That doesn't always happen. I pick on XUnit a little bit here, but if you specify to the XUnit console runner that you want an output report file generated and you want it to put into this location, XUnit console runner doesn't actually create that folder for you. So the build will actually fail. So again, in terms of taking ownership of the build and making sure that everything's working correctly the way you want it to, what you should do as part of your build is to create that folder. So it's a little bit of duplicity, I was going to say, in this particular scenario, because it's not a requirement, it happens to work. But again, in terms of being a good citizen, you should create that. So the way that we can do that is with another alias that ships with Cake. So we go here at demo 4. So what we're going to use here is the clean directory alias. So what it's going to do is it's going to make sure of two things. It's going to make sure that the directory that you specify, or multiple directories if you use one of the other aliases, it's going to make sure that that file folder exists, and it's also going to make sure that that folder is empty. So again, in terms of it being repeatable, it's going to make sure that all the artifacts of that previous build are cleared out, and it's only the outputs of this new build that we're running that's getting put into there. So to make that work, I'm going to get rid of that. What I need to do is I need to chain another dependency onto this publish step, because I've said that this publish step now has two dependencies. It has a dependency on the build, and it has a dependency on the clean task. So if I save that, and I'm going to expand that folder, and I'm going to run it again, what we should see happen as part of the build is that that build artifacts folder is going to get cleared out, and it's going to get repopulated by the publish step. So again, it's not real, there's no magic happening here. It's literally all the things that you would either need to do manually or is kind of done implicitly for you. You're taking an explicit decision to make that happen as part of your build. Okay? All of that making sense so far? Good. Okay, so in terms of what we said we were going to show, I said I was going to show the NuGet package restore, I was going to show the build, I was going to show the publishing and the cleaning. So in terms of demo content for my build.cake file, it's now doing everything that I hoped to do. So the demo gods were polite, and that allowed that to work correctly. What I'm going to show now is two of the most requested features for Cake that are now available within the current version of Cake. The first one is the ability to debug your Cake script. So one of the advantages of Cake is that you're running on, say you're running on a CI server, you can run the same build locally as you would on your CI server. So that means that you can run the build locally, and then if that build fails locally, then there's a strong chance it's not going to build on the CI server. So that's one of the benefits of using something like Cake. However, when you are building that Cake file and you're adding new steps to it, or you're trying to figure out why something isn't working, it's useful to be able to debug the script. And because it is just C#, it is possible to debug that script. I do say that with a small caveat, in that if you are wholly reliant on the debugging functionality, then you're sort of doing something wrong, because you can't debug it once it goes onto your CI server. So you need to make sure that you've got an adequate level of logging and metrics so that you can debug a failing build on the CI server. And what that looks like in Cake, for example, is we have the information alias that allows you to write out random pieces of information into the output log, so you can see what's going on, and obviously the tools that you're executing are actually going to add stuff into the log as well. So debugging is great, but like I say, I want to make sure that we're using it wisely. But what that looks like, if I set a breakpoint down here, so within Visual Studio Code, I can literally, I'll put it down here actually, I can set a breakpoint. So that breakpoint is there, and as soon as I hit F5, which is the standard keyboard shortcut in Visual Studio Code to actually initiate a debugging session, what's going to happen is that that breakpoint is going to be hit. He says, there we go, right, so we've got a breakpoint, we've hit that breakpoint. So what that allows us to do now is within that settings class, we can now see what the configuration value has been set to. It's been set to release, because that's what the default value is. But now that we're in this debugging window, we have access to the watch window, we have access to breakpoints, we can do all the things that we can do normally, but in the context of our build script. So if we want to step through a build that isn't working, we can do that just with the standard keyboard shortcuts of F10. And what you'll see at the bottom in the terminal window, it's actually, the build is still progressing, but it allows you to debug it. Okay. Now, the reason that that just worked on my machine was because I've got this thing called the launch.json file. The launch.json file controls how you orchestrate some of the functions within Visual Studio Code. In this example, what I'm doing is I am using Mono to be the runtime for cake.exe. So when I started the debug session, it started up Mono, it executed cake.exe, and then it did all the standard stuff that I spoke about in that workflow. The reason that I'm using Mono is obviously I'm on a Mac, so I don't have .NET Framework there. But the other way that you can run Cake is with the .NET Core runtime rather than with Mono. So the way that that looks is in the Cake extension, there's a second entry that you can add into the launch.json file, which is this debug script Core CLR. So if I click on that and get rid of the first one, which was up here, we can now do the same debugging feature, but this time we're going to use .NET Core. Now, if I go ahead and back to my build.cake file, I've still got my breakpoint. If I hit F5 and debug, it's not going to work very well, and it's got an error. And it's going to say, well, yeah, launch program, yada, 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 doesn't work. The reason that that happens is because I don't have the Cake Core CLR available on my machine just now. So I refer back to the earlier slide when I said that cake.exe can either, the Cake executable can either be a cake.exe or it can be a cake.dll. So the cake.dll is our .NET Core version of Cake. So we compile Cake twice. We've got full fat framework Cake, and we have a .NET Core version of Cake. So I don't have that locally on my machine. So within my launch.json file, I'm specifying that I want to run that cake.dll. I don't have it. So the way that you can get that is if you go back to some of the commands that we provide within Visual Studio Code, then there's this one that says install debug dependencies. If I go ahead and click on that one, what we'll get in our tools folder is the cake.core CLR NuGet package restored into the tools folder. So now if I go ahead and run F5, we should initiate the .NET Core runtime. It'll pass off to Cake. Cake will be executed. It'll compile the script, and what we'll get is that breakpoint being hit. So depending on what environment you're running in, you need to control that entry point and how you're running Cake. The reason that that's important is because some of the third-party add-ins that we have, some of that 200 third-party add-ins that we have, they don't compile that add-in for both full framework and for .NET Core. So depending on what add-ins you are pulling in, from a debug point of view, you might have to use one or the other, but you have the option of using both. Okay, so again, under the .NET Core runtime, we've got that same debug functionality that you'd normally expect. Okay, so that was really that was one of the bigger features that was always being requested. I gave a similar talk to this a couple of years ago at NDC, and everyone was asking, well, why can't I just debug it? So we finally got round to adding that in. The other one that was a common request was, okay, it's just C# and I'm in an IDE, why can't I get IntelliSense? Why can't I have the same IntelliSense that I get when I'm writing my web application, because it's just C#? There are some complexities around that because it is just C#, but obviously during the compilation step that we do, we are adding in, or we're allowing the addition of those higher level DSL aliases that I spoke about. So it's not just a straight direct implementation of C#. So there's some caveats to that. But what we do have now, if I go and just start writing something like information, then Visual Studio Code at the minute is telling me, or it's making a suggestion as to something that I can add in there. It's doing that because I've got an information elsewhere in this file. So there's not any smarts just now. all it's saying is, you've written information before, is this what you wanted? Yes. So that's not IntelliSense. However, if I go ahead and run another of those cake commands, and the cake command that I'm going to point out here is the one that says install IntelliSense support, what that's going to bring down into our tools folder is this thing that we lovingly call the cake.bakery. Because why not, right? Yes, we've got a bit of a pun going on there, but it's great. So we've got the cake.bakery. So what cake.bakery is going to do is it's going to be the interface between Cake and this thing called OmniSharp that you might be familiar with. So OmniSharp is a service that is installed on lots of the text editors, so Sublime, Atom, Visual Studio Code, and it sits there and allows understanding, and it's the thing that adds the IntelliSense. But what cake.bakery is doing is it's handling the smarts and the handing off between the DSL that we create and C#. So the one caveat that you have to watch is that as of right now, having installed cake.bakery into this project, I actually need to force a restart of the OmniSharp server. So what I'm going to do is just restart that OmniSharp server. So now what I'll get is if I go down to this line again and start writing information, and I spell it correctly, then what I'll now get is now I've got IntelliSense. Now I've got information about the alias that's available with that name. So if I go ahead and finish typing that out, what I'll get, obviously then, are the overloads that are available for it. It's the standard functionality that you expect from IntelliSense. So for the information alias, doesn't give me a lot because there's not a lot to it, but what it does give me now is that right now I've got a compilation error. I'm missing my semicolon, the important semicolon at the end of that line. I'm now getting that red squiggles within the IDE to tell me that that script's broken, so I can see it straight away rather than trying to execute the build and having an error come up when I actually try and run Cake. So you're getting that functionality now through OmniSharp. So something like the information alias, it doesn't really prove that much out, but down here, if I were to bring up IntelliSense, then I can see all of that information that's available to me to say what parameters I can pass into that alias. Now what I do say and what I do encourage is, if I can find it, on the Cake website, there is documentation. We do have documentation, so I would encourage you to use that documentation and not just rely on IntelliSense. But obviously now that we've got IntelliSense there, it is something that's very useful to have in the IDE to make writing of that Cake scripts that bit easier. Okay? So with that, that is kind of everything that I wanted to show. So are there any questions about anything related with Cake? No? Okay. Anyone using Cake already? There's a few, I know at least one. Okay, hopefully I've shown you some stuff that's of interest, and I'll encourage you to go and look at it. If you are interested, then there's a bunch of resources available. We've done some podcasts, we've done some videos, so on. They're all available really just off the Cake website, but there's some direct links there. And with that, I'm done. So thank you very much.